Good afternoon. Welcome to course Thermodynamics of Materials. Today we are into lectures 181 and 182. So we'll resume talking stability diagram construction of system Fe2O involving Fe, FeO, Fe3O4, Fe2O3 and carbon, all pure solids and the gas phase containing CO2. So we have actually already finished in the last class the equilibrium between Fe and FeO, means this curve, GCF, Fe, FeO, this curve. Already finished. Today we'll pick up the second one, that is this curve, GDH, FeO and Fe3O4, FeO and Fe3O4, and the gas phase. Gas phase is actually referred to in the on the y-axis, on the axis, and T is the temperature on the x-axis. So this is the second case. Third case will be what? This one, this curve, GJ, that will be Fe3O4, this one, Fe3O4, and you have actually Fe3O4 and Fe3O4, like this, FeO, Fe3O4, Fe3O4, Fe, these three curves. One, and then last we will take up this curve, EK, that is Fe3O4 and Fe2O3. So we will go down to the stage of Fe2O3 and superimpose on it will be this curve, A, B, C, D, E, means the carbon curve, the famous carbon curve, that is the reaction CO2 plus C is 2CO, that will take up. This is actually carbon saturation curve, means activity of carbon is 1. Not only that, we should specify the pressure, because this is a pressure dependent curve. So pressure of 1 atmosphere I have written somewhere, P is 1 atmosphere. Activity of carbon is 1, which we actually speak in terms of saturation, carbon saturated curve. So activity of carbon is 1 and total pressure is 1 atmosphere. This also I will take up. So total altogether 1, 2, 3, 4, 5 curves. 1 already done. So 4 will be coming today. Then this construction will be over with some discussions and clarifications. Okay, this one. Okay. This I wanted to tell you. These curves will be, this will be right. And the y-axis is percentage CO in CO2 mixture. Remember, percentage CO in CO2, not CO2 nitrogen. In blast furnace, you actually blow air. Not only oxygen, nitrogen goes. So no. The nitrogen you have to. This is only the CO2 content. So if you have actually have infiltration of nitrogen, or if you have the presence of nitrogen in the gas phase, then you have to apply properly, suitably. Okay. So what is the percentage? You have to exclude nitrogen and find the percentage CO. Total pressure is 1. So this is critical things. Okay. This is complicated things, so no problem. So this is called stability diagram for the system FeCO. So we start with the second one. Right. So we begin with the second one. Yes, here we go. It here. So this is the system. Okay, stability diagram for the system Fe FeCO. Okay. So let us take up the second, means this one, FeO, Fe3O4. So what is the equilibrium under study? Is Fe3O4. And by the way, for the time being, don't consider this diagram as well as this diagram. Look away from these two diagrams. This will be taken up after this is over. That is actually, this, see, you have seen, this is something, okay, this is actually a different plot, log PCO versus log PCO2, and this is reproduced here with some actually additional lines, and actually, and with some purpose different, okay. There, so these two will be discussed together. Is the next example. 4. 6 examples will take. We are discussing the application of the phase rule. 6 we will consider. Okay. So 3 now. Here this is construction of stability diagram. 6 examples. Now we are into the third. So let us write this FeO. Fe3O4 solid plus CO gas goes to 3FeO solid plus CO2 gas. Call it equation, this will be equation 3, I am sure. 1, 2 already covered in A. A means in the discussion of FeO equilibrium. That is the curve GCF. Now we are taking up GDH. What is the purpose? We will try to develop the equation of the curve, and then everything is settled. If the equation is known, then we can plot it. So that is the purpose. So GDH, what is the equation? Let us proceed this way. So this is this equation 3. So what is this? Delta G0, as you know, delta G03 is your A plus BT, where you know A and B are known quantities. A is delta H0 and B is minus delta H0 from the data book. Actually, I give you these values because I have got these values with me. Okay, so it is better. Yes, correct. 3 is okay. A plus BT is what? His value is 380. It may help you to have the data. Minus 35.12 T joule. This is your, this is minus RT ln K, as it should be. RT ln K is what is RT ln K, or what is the expression for this? Is let us not waste space. Minus RT ln, what is the K? K is what? A activity of FeO solid cubed times PCO2 over activity of Fe3O4 solid and PCO. Okay, solid, and you know very well that these are the pure state with activity 1, or you get what is in the right here. RT minus is actually absorbed upside down, RT ln PCO over PCO2. Obviously, this is at equilibrium. This is at equilibrium. This is the equilibrium diagram. Okay. So you may write here, if you are interested, you may write this. Okay. But when you know that this is under equilibrium. Under equilibrium. Okay. Under equilibrium. Okay, just you understand. So this is, but we actually, since we understand that this is the PCO by PCO2 at equilibrium, okay, this equilibrium value will be plotted here, but we will actually do some, or PCO by PCO2 is what? Can you tell me what is PCO? It is nothing but A plus BT over RT. Not only that, exponential, no doubt, okay, is what? Or just continue, PCO over PCO plus PCO2, this manipulation will do this, exponential A plus BT over RT divided by exponential A plus BT over RT, and it will be plus 1, okay. Or what is the name of this? You recognize this is the mole fraction, okay. So or percentage CO is plotted. So this is totally an equilibrium diagram. Stability diagram means equilibrium diagram. Or what, tell me? Percentage CO, which you know as 100 times X CO. X is the mole fraction of CO in this mixture, CO2 mixture. What is the mole percent? Mole fraction to 100 times exponential A plus BT by RT and over exponential A plus BT over RT plus 1, as you see. You box this. This is the important finding. This is your desired equation 4. This is the equation for the curve GDH, or the equilibrium of FeO and Fe3O4 means this equilibrium. This is the equation. Okay. So percentage CO versus T. This is non-linear, clearly non-linear. So, and it is also here, as you see, non-linear. So let us write this. Hence percentage CO versus T plot is non-linear. Last time also it was non-linear. This one non-linear. Similar, actually exactly similar. You may check back. Is non-linear. Is non-linear and given by the curve GDH. Okay, along the curve. So what is always, you know, you are used to this. You are okay. You seem to be expert. Supposed to be expert in this. That what is the meaning of this? Along the curve, these both solids coexist. Above the curve, the one when percentage CO increases, FeO. Above the curve, FeO is stable, singly, alone with the gas phase, But FeO of these two phases, FeO alone is stable, and below the curve, Fe3O4, the other one, Fe3O4 is the stable. Okay, so let us write that down here. Along the curve, FeO solid along the curve. FeO solid and Fe3O4 your magnetite. FeO is woostite and Fe3O4 solid coexist. And Fe2O3 is hematite. Okay? So coexist. Right, coexist. Above the curve, who present? Above the curve, FeO, above FeO solid. FeO solid, and below the curve, Fe3O4 solid are stable. Achha, right? Above the curve, FeO is solid. Achha, it is better, right? Fe3O4 is stable, right? And below the curve, Fe3O4 solid is stable. Above the curve, FeO solid is stable, and below the curve, Fe3O4 solid is stable. Okay. This is over. B is over. C. Next one, as I told you, consider this curve or this relation. See, suppose you don't have the curve with you. You don't have this diagram. You will draw the diagram. You are in the preparation to draw the diagram. These are the preparatory steps. This is the equation. Once you get the equation, then you can draw the curve. So similarly, for which equilibrium you consider? So, repeat. First one, FeO. Second, FeO, Fe3O4. Third would be obviously cyclically Fe3O4 and Fe. That means this curve, Fe3O4 and Fe. Okay, so take up equilibrium C. Fe3O4. In the same manner, right? Gas phase. Gas phase is CO. Equation, what equation it will be? 3, 4 over, it should be 5. Again, as before, delta G05, just as before. Delta G05 is what? A plus. I tell you one thing, in passing, you see, this is actually rising upwards. The one, A, last step. GC, FeO equilibrium curve, rising upwards. Now this we are going to draw this Fe3O4 is also rising upwards. And the bottom one is Fe2O3, Fe3O4 is also rising upward. But the one that we finished just now, FeO, Fe3O4 is descending. Okay, right. Okay. Is actually have a negative slope. So it is descending type. These are ascending type. This is descending type. This is rising upward. This is sinking below, downward. It is moving downward. Why this difference? Why? The source is what? Source is where? Delta H0. If you check last case it was negative. If you ask me the value I can give you minus 17,230. Exothermic, this you can very easily verify why this happened, because we went percentage CO, as temperature increases, equilibrium CO will increase. In these exothermic cases, like here as temperature increases, percentage CO or PCO will increase, and also here. But in this case, the opposite, percentage CO will decrease as temperature increases. Reason? This is not exothermic, this is an endothermic reaction. So very easy, you can follow. So you should note this actually. Remember this figure, always remember this is very important figure. In direct reduction, in iron making, very, very, very important. Iron, carbon, oxygen, equilibrium diagram. So you should note that the slope is ascending type. All 1, 2, 3. The fourth one is descending type. Carbon curve I have not said anything. This is the carbon A, B, C, D. This one I have not yet. We have already read number of times, but this will include here also. This is a different type curve. Okay. So that is different issue. So delta G is A plus BT. So guess it will be what? Here APPC it is also again exothermic. So what is that value? In case you are interested, so you write first. This is the known quantities A and B. And what are those quantities? Minus 21,160, 610 rather, 610 plus 27.52 T joule is what? Actually this is simply go this way. Is what? Minus R T ln K. What is this? It is better I write this side is minus R T ln. What is the equilibrium constant? Right? Oh, I'm sorry, I have not written the reaction first. Reaction should be written. I'm very sorry. Should I insert here? I write the reaction here. So Fe2O3, I'm very sorry. Fe2O3 reaction or equilibrium. Fe2O4 solid plus CO gas. Oh, this is not 5. This is not equation 5. This is the title. Subtopic title. This is not 5. This is going to be 5. Plus CO gas goes to what? 3 FeO. Oh, this is not FeO. I am very sorry. This is Fe. Fe2O4 Fe. Apu, take a look here. Whether this is last line that's something. This gap.
Yes. Last line.
Every time we check this. Every time. And this is very important.
Okay.
Thank you.
But that one is not visible.
This is
No, not that one. Below that, the marker, yes, that is not.
This is not so important.
Yes, but the last the written that one is visible.
Every time you check.
Okay.
Minus RTL and K. I'm very sorry. The reaction I have not completed yet. Have you got this? This is CO gas plus CO gas is what? Fe. I'm very sorry. Fe plus CO2 gas. I'm sorry. 3 Fe2O4, it is 3 Fe. But 4O, it is 4 CO, 4 CO2. 4 CO, 4 CO2. Okay. So this is your okay, the balance equation. So now take all this one will be your equation 5. So I repeat, Fe2O4 solid plus 4 CO gas goes to 3 Fe solid plus 4 CO2 gas. So minus equilibrium constant, please write this activity of Fe cubed solid times PCO2 power 4 okay, over activity of Fe2O4 solid times PCO power 4. As before, you put 1. This is also 1 pure solid. So what you are getting here is RT ln absorb minus PCO over PCO2 power 4, so it goes to this side is 4RT, or you write in this way, or PCO by PCO2 write, or PCO over P, like this, PCO by PCO2. PCO by PCO2 is exponential what? A plus BT over 4RT. Instead of RT, this is 4RT. Okay? Or what you want to do this here. This is 1. Alright, let us keep on writing. PCO by PCO plus PCO2. PCO is what? Right, similarly, exponential A plus BT over 4RT, exponential A plus BT over 4RT and plus 1. This is known as what? Tell me. XCO, mole fraction CO, XCO, or mole percentage CO. So I write here, then it will be all over actually here. So let me write, then we will cover these two. Okay, or let me write here, or percentage CO like this. I will box it 100 times. Right, 100 times exponential A plus BT over 4RT divided by exponential A plus BT over 4RT, plus 1. And now we may highlight this as the final result, the equation of our desired curve. This is the equation. So call this what number? 5, 6. So like this, hence you will write this. These comments you write it not here, you start here. Where? Since this is already over, B is already over, no problem, remove this. C already over, so you write this star from this point. So like this, hence, what is your observation? Percentage CO versus T is a non-linear, and this is the non-linear. GDH, curve GDH. Again, along the curve, both coexist. FeO and Fe2O3 coexist. Above the curve, FeO solid. FeO alone is stable, and below the curve, Fe2O3 solid alone is stable, along with the gas phase, always, okay, both, okay. So here when they are coexist, FeO, Fe2O3 coexist along the curve, they coexist along with the gas phase. Gas phase is always. So let us write here, we are waiting. Hence percentage CO versus T plot is non-linear. This is the comment we will make, non-linear, and okay. And what else you will write here? is non-linear, like this. Keep on and copy this, and given by the curve, which curve? Curve GDH, given by the curve. Oh, I am very sorry. Oh, how I made this mistake. No, correct. Oh, I am very sorry. Which equilibrium constant? Fe2O3 is given by which curve? This one. And I am very sorry. This equation represents which curve? GJ. Equilibrium between Fe2O4. Forget about this carbon curve. Forget. Fe2O4 here. This stability domain is Fe2O4. Clearly see. This, forget our carbon curve. This is FeO, and above is iron. So it is equilibrium between Fe and Fe2O4. This is the equilibrium reaction. This is a reaction. Okay, Fe2O4. So I am very sorry. I am given by the curve. Which curve? Not. This is already over. GDH is already over. This is for Fe2O4, FeO. I am very sorry. This Fe2O. I repeat then. This is Fe2O4. Fe2O4. So like rotation. In rotation, FeO, Fe2O4, Fe2O4, Fe. So this is along this curve GJ. Fe2O4 and Fe coexist. Above the curve, Fe is stable, and below the curve, Fe2O4 is stable, along with the gas phase. Okay, so this we are going to handle are given by the curve GJ. Along the curve, like this way, along the curve, Fe solid and Fe2O4 solid coexist. Then above the curve, Fe. Above the curve, Fe. This is the stability domain for Fe. This one. If you ignore carbon curve, ABCD curve, this curve, here above this curve, Fe. Okay, like this. This is domain for FeO. This is a stability domain for Fe2O4. This is the stability domain for iron. So along this curve, Fe2O4 coexist. Both. Above the curve, Fe, below the curve, Fe2O4. As it above means with increasing percentage CO or PCO. So if you increase the CO content, there will be push from the left hand side to the right hand side, and Fe will be stable, as you see. And the opposite will happen when you decrease the CO. Okay, you understand? So this is, yeah. Okay. Above the curve, who is stable? Above the curve, Fe solid. That is right. And below the curve, coexist. I am sorry, I missed some. Coexist. I have forgotten that case also. Coexist. No, is okay. Acha. Is okay. It's okay. Acha. Above the curve is okay. Above the, I repeat. I tell you. Here you should write, to be precise, along the curve Fe solid and Fe3O4 solid coexist along with the gas phase. Similarly, here above the curve Fe solid and below the curve Fe3O4 are stable again along with the gas phase. Gas phase is given by this. So any point you are interested, gas phase is obtained from the composition from the y-axis. So you refer to the y-axis to get the gas phase. So this part is over. So so how many is over? C. Next is what? Whose turn is next? So remove this. Whose turn is next? This curve. Fe2O3 and Fe2O3. I tell you what, one thing, in many textbooks and research papers, you may not see this curve, Ek, because this is so close to x-axis, tends to merge with the x-axis, so they are not, it is not easily discernible. So many prefer to omit that line. But we know the starting point is Fe2O3. So stability field of Fe2O3 is also important. And equilibrium between Fe2O3 and Fe3O4. In fact, if you ask me, I will tell you further. So here also, this is actually Fe2O3, Fe3O4 line which we will take up now. Ek, which is often missed out in textbooks. So we'll include. And it's okay. And then I tell you what, if you want to know, so let me finish this, or I may forget actually, that's why I said. Then you see, he extend this, they'll intersect. So what is this? Fe2O3, Fe3O4. This is this line, and this is Fe3O4, FeO. And where they intersect, there will be a new segment emerge from the intersection point. Which one that will be? Fe2O3, FeO. So much, but this will be so large, so high a temperature that this is totally not considered. Even not only that, even this line is ignored. But I always like to have my students to be fully aware of the stability fields and to have the complete picture, not actually truncated picture. Why Fe2O3? Why is Fe2O3, sir? You are talking of FeO, Fe, Fe3O4. Why is Fe2O3 if this is asked? Now can you show us? And even more intelligent student will ask, sir, then why is the Fe2O3 and FeO line? Then teacher will explain that if we extend this, they will intersect from that point, the third. Always that's the triple point. That will be triple point for the three phases, Fe2O3, Fe3O4, FeO. So don't worry about so many things, okay? Now for the rhyming, only take up what I say, C, D. Take up D. What is that called? Write the same way, equilibrium. Write this equilibrium, Fe3O4, Fe2O3, and of course the gas phase. If you have, alert you, if you have like blast furnace situation, as in blast furnace situation, nitrogen also, CO2 nitrogen, very practical. Very, very practical. Not only CO2, but it is simplified version for easy learning. First you comment this, then you complicate with nitrogen. That's why nitrogen is not included. But if, or argon for that matter, or something else, the third component in the gas phase, then you exclude nitrogen and see from the remaining amount what is the percentage of CO and percentage of CO2. The percentage of CO, apply this curve. Exclude nitrogen, and of the remaining gas, then the remaining gas, what is the percentage of CO and percentage of CO2? Considering this as a, okay. Now then what will happen? Then I tell you what. Then actually what will happen? This is remember, this is drawn for 1 atmosphere. If nitrogen is 50% say, then what is the total pressure constituted by CO2 is 0.5. So you have to draw a new curve corresponding to 0.5 atmosphere, and then you apply. And you know the percentage CO and percentage CO. You know here the gas composition. So like this, okay. So there are intricacies, but you have to be smart also. So equilibrium this. So our purpose for the time is drawing the line EK, okay. EK, okay. So this is what is right. Remove this. What is first write the reaction properly, okay. Right. Fe2O3 solid plus CO gas goes to Fe3O4 solid plus CO2 gas. And this is 3, this will get a 3 here, and that will get a 2 there for iron balance. Then you have 9O, there is 8O, but there is CO and CO2. So balance, this is now the balance step. Once it is balanced, you start from here, delta, give a name to this. This which equation you tell me? Tell me, last one was 6, it will be 7. 7, okay. Again, similar manner. Okay, start. Delta G0 7 is A plus BT. AB known. Okay. Again, as I told you, I am giving you the data. So this data actually, since I have with you, I have with me, so I am just furnishing the data, and it may be useful for you. What is this? This will be, as I told you. See, I give you. I give you that this is also an exothermic. All exothermic, excepting this one. Very easy to remember. All exothermic here. 1, 2, 3, 4. Okay. So this is endothermic. So this is exothermic. Then that will be what? This will be ascending type. And actually it is ascending type. You see. Right? Clear? So A plus BT is what? Ascending. What is the meaning of this? Okay. Exothermic, as I told you, the equilibrium constant. Exothermic equilibrium constant. As temperature increases, equilibrium constant decreases. And the equilibrium constant decreases means equilibrium constant here CO2 over CO. So CO2 by CO decreases means CO increases. And yes, sir, that's right. Okay. A plus BT is what? Let us pick up this. Minus 42970. Okay, 7. Minus 42970 minus exothermic, as I told you, 40.07 T joule. Okay, this is what? Remove this, no problem. This is what? Remove this. This is what? Like this is minus RT ln K. Minus RT ln K, you know what is this? Then you keep on writing like this. Minus RT ln K is minus RT. What is your K? K is what? Okay. Activity of Fe3O4 solid squared PCO2 over activity of Fe2O3 solid cubed PCO. Again I repeat, if you are interested, right here at equilibrium. You may add at equilibrium, but this is equilibrium diagram. So what is the value of this? 1. This is 1. So what you get from this? You write here RT ln PCO over PCO2. Absorb the minus, or PCO by PCO2 is what? Right? Or PCO over PCO2 is what? A plus BT over RT. Not only that, exponential, no problem. Or PCO by PCO plus PCO2 is what? Exponential A plus BT over RT divided by exponential A plus. If you consider the whole is numerator, then denominator is what? 1. So that's why 1 is coming. A plus BT by RT plus 1 plus 1. This is known as XCO, mole fraction. Or you write percentage CO like this. Or percentage CO is 100 times. This is mole fraction, mole percent. Percent means mole percent. Or mole percent CO. Why mole percent CO? Because this what is mole percent CO? Percent CO means mole percent. Oh, remember this. This percent is mole percent. Okay? Mole percent CO. Volume percent. Okay? Volume percent is a function of pressure, temperature. You have to specify the temperature pressure. Mole fraction, mole percent, no problem. You don't have to mention. Okay? Mole percent, weight percent, another way. Weight percent is actually you have to bring into molecular weight. Okay? So, but mole percent for gases is okay. Fine. Mole percent. Volume percent, another popular use, but remember, volume percent is actually that we know actually 1 gram mole occupies 22.4 liter at 273 Kelvin and 1 atmosphere pressure. We have to introduce those things, okay? The temperature pressure. But this is very simple. Mole percent CO is 100 times exponential A plus BT by RT over exponential A plus BT over RT plus 1 and box it. This is your desired relation, mole percent CO versus temperature. Only. But no problem. You know A and B. So it's consider any temperature arbitrarily and find the mole percent. Again another temperature, find mole percent. Again another temperature, find mole percent. Another temperature, mole percent. Another temperature, mole percent. And then connect these points into a smooth curve, GZ. Or you may take help of programming, no problem. Once the equation is. What is the equation number? It will be 8, 7, 8. Okay, remove this. So 4, A, B, C, D, 4 over. So fifth curve is what? As I told you, the carbon curve. If the iron, carbon, oxygen, you can ignore carbon curve, then this is, here I have shown. Then this is the result. But you will superimpose carbon curve for some useful information. Very useful. Very useful information. That I will discuss at the end. So that's why we will superimpose carbon curve. So we must in the similar manner find the equation for the carbon curve. What is the carbon curve? A, B, C, D, E, which we have already studied a number of times. But still, for the sake of completeness and for the sake of this construction, we will again take up this one. This is the E. What is that? Carbon carb means this reaction. CO2 plus C is 2C. Equilibrium under activity of carbon 1, which we call carbon saturation. And this is a pressure specific reaction. So that's why pressure should be mentioned, and we have considered here 1 atmosphere total pressure. Total pressure. Another thing I have missed perhaps, but you should know it. What is the effect of pressure on these curves? Which is A, B, C, D. These four curves, namely, tell me. First day, last previous curves, G, C, F. This curve, what is the effect of pressure? This is temperature pressure, no effect. Because same number of moles of CO and CO2, no effect. Number of moles of gases are same in all cases. Here, all cases, if you look back, all 1 mole, or 4 mole, same number of moles. So no pressure independent curves. These curves are pressure independent. So in the expression there is no pressure term. No pressure. But this will entail in pressure because not same number of moles of gases involved. Why? 1 mole CO2 plus C is 2 CO. 1 mole CO2 on the left hand side and 2 moles of CO on the right hand side means it is a pressure dependent equilibrium. So we should specify pressure, or we should draw for a specified pressure. And if the pressure changes, curve will change. This we discussed. E. Start E. Equilibrium. Carbon solid and gas phase. What is the gas phase? CO. What is the reaction? First of all, you should write the reaction. Very easy reaction. CO2 gas plus carbon solid is 2CO gas. What is the equation number? 8 here, 9. Remember, we will superimpose this curve. We will find the equation and the curve generated by the equation, that is ABCDE, will superimpose for some very, very useful information, inferences. Like at what temperature you should, at what is the limiting temperature that you can reduce iron oxide by carbon. Typically say Fe2O, very important, difficult oxide, pushpile. What is the limiting temperature? Now above which temperature we can, or below which we cannot. Such questions will be answered if we superimpose this diagram on this diagram. This we will discuss. First let me draw the diagram. Draw the curve, carbon curve. AB, that is actually ABCD. Some books say, or some people say, boudoir curve. Some say solution loss reaction, like such names. But you should specify the reaction. CO2 plus C is 2C. 9. Start like before. Delta G0 what? How to start here? Here like this. Delta G0 9 is what? Right here. A plus BT as before. A plus BT. And what we will mention here, these are known quantities. And again I will give you data for this. Data 166 560 plus minus minus 171 joule. Okay, this is an endothermic reaction. Okay, so what is the consequence? This I discuss. As temperature increases, percentage CO will always increase. See clearly, if you accept this curve, as temperature increases, percentage CO, temperature increases, percentage CO increases. But which manner? That is a non-linear manner, complicated equation. That is joule is minus RTL and KL. Let's give a star here. Give a star, double star. Double star. Remove this. Remove this. These are all over. Is okay? These are all over. Remove this. Double star. Continue. Is minus equilibrium constant. What is equilibrium constant? Right? PCO square PCO2 activity of carbon solid. You know very well this is one. This is pure solid. Carbon saturated we say. Or keep on writing this, okay? Continue. Is what I am writing. RTLN PCO square. What is PCO2? 1 minus PCO. 1 minus PCO. Okay, why? Because total pressure is, since PCO plus PCO2 is 1 also. Total pressure. So this diagram is meant for 1 atmosphere total pressure. Okay, so this, then once it is this, or PCO square, or let me write, or PCO square over 1 minus PCO is what? A plus BT minus A plus BT by RT. Do you agree with me? Minus A plus BT by RT. No, you don't agree with me because there is a ln there, so exponent is there. This is the speed relation which is what it is, which is percentage CO. This is PCO versus T, which is percentage CO, which is nothing but 100 times PCO by total pressure, P total, which is 1 atmosphere. So this is PCO versus T, so we can get percentage versus CO versus T also. This is actually, you can find out that choosing, selecting some temperature, you can always get this. Okay, so this is a quadratic equation. It will be given the temperature. This is a quadratic equation in CO and get the value also. So PCO form and percentage CO for that temperature. So again you get a percentage CO versus T for number of cases, then generalize the equation. So anyway, I am giving the outline. Percentage CO versus percentage CO versus T relation. At careful always of that at 1 atmosphere total. This never forget. This is the percentage C over 60. This gives rise to percentage C over 60. And what is the outcome? The curve ABCDE. This famous curve, carbon curve. Okay, I don't know to talk about this. Hence, it is a what? It is a 42 non-linear, and this is of course non-linear. Bapo. This is a non-linear curve. As you see clearly, this is a non-linear relation, non-linear. How will close? I have some pain and abdomen. So this is where this is actually a non-linear. I will pick up from this place next class. Okay. Thank you. Today we have to stop here, and I will resume from this point. Okay, and then we will pick up the fourth example. So next class. Thank you very much for today. So today we have to we have to end the class right here, and we will see you next class. Thank you for your patience and for your encouragement, for your energy and for your cooperation and for all these things, sincerity, everything. Thank you. See you next class. Bye.